full chapter of basic concepts of chemistry using my personal tricks. The first topic is matter, which is divided into pure substances and impure substances. We know that pure substances contain same type of particles. For example, consider iron sheet and sodium chloride. We can see that this iron sheet contain one type of particles. These all particles have same properties. So we say that iron sheet is a pure substance. Secondly, this sodium chloride also contain one type of particles. All the particles have same properties. So we say that sodium chloride is a pure substance. Here, let me teach you one exam question. Why elements and compounds are called pure substances? Well, the answer is simple. They both are made up of one type of particles. So we say that elements and compounds are pure substances. For example, like iron sheet, gold, sodium chloride, silver, etc. On the other hand, impure substances are those substances which contain different types of particles. For example, consider salt solution and salad. We can see that salt solution contains two types of particles. Secondly, they have different properties. So we say that salt solution is impure substance. On the other hand, we can see that in salad, there are more than two types of particles, and these particles have different properties. So we also say that salad is impure substance. Here, let me teach you another exam question. Why mixtures are called impure substances? Well, mixture are called impure substances because they are made up of different types of particles. Remember the name of these important mixtures like air, seawater, solutions, suspensions, colloids, and alloy like steel, which are usually asked in MCQs. So remember about pure substances and impure substances. The second topic is properties of matter, like physical properties and chemical properties. We can easily observe physical properties without changing the identity of a substance. Now how we can remember the physical properties of matter? Well, I always use my personal trick. Moving van should come late. Here, M stands for mass, V stands for volume, S stands for shape, C stands for color, L stands for length. Also remember that all physical changes like melting point, boiling point, evaporation, sublimation, and condensation are physical properties. We can observe chemical properties when a substance changes its state. Now how can we remember chemical properties? Well, we say that moving van should come late. In case of chemical property, we say that Amir bhai will come. Here, A stands for acid, this S stands for air, B stands for base, W stands for water, C stands for chemical. So a reaction of acid, reaction of air, reaction of base, reaction of water, and reaction of chemicals all possesses chemical properties. Thus noted down physical properties and chemical properties. Now let me teach you the third topic, physical quantities. Well, anything which we can measure is called physical quantity. For example, consider 12 kilometers or 12 hours. Here, we can measure the length of anything like 12 kilometers, so length is a physical quantity. Similarly, we can also measure the time like 12 hours. So time is a physical quantity. This topic is divided into three subtopics like base physical quantities, derived physical quantities, international system of units. Now what are base physical quantities? Well, the 7 physical quantities in terms of which other physical quantities are expressed are called base physical quantities like length, time. Secondly, those physical quantities which we can derive from the base physical quantities are called derived physical quantities. For example, when we divide length by time, we get speed. Here, we know that length and time they both are base physical quantities, but dividing them, we get another physical quantity like speed, which is known as derived physical quantity. Now what is International System of Units? Well, in 1960, an International System of Units were established for 7 base physical quantities, which we call International System of Units. Now how to remember base physical quantities and International System of Units? Well, I always use my personal trick. I say Lisa ma'am turns to a left edge. Here L stands for length, M stands for mass, T stands for time, this T stands for temperature, A stands for amount of substance, L stands for light intensity, E stands for electric current. The SI unit of length is meter, the SI unit of mass is kg, the SI unit of time is second, the SI unit of temperature is Kelvin, the SI unit of amount of substance is mole, the SI unit of light intensity is candela, and the SI unit of electric current is ampere. Remember that except these all 7 units, the rest of units are called derived units. Also, let me teach you one bonus question. What is the difference between mass and weight? Well, mass is the amount of matter present in any object, while weight is the force between the earth and an object. The SI unit of mass is kg and the SI unit of weight is Newton. So note it down all these important points. Now coming to the fourth topic. The fourth topic is about prefixes. A mnemonic that is added to units to show multiples or fractions are called prefixes. For example, consider 2 kilogram. Here, gram is the unit and kilo is the prefix. Now how can we remember the list of important prefixes? Well, I use my personal trick. I always write 10 to the power 1, 2, 3 and then I jump 3 times 6, 9, 12. Now I say Dad has kept my great trick. This D stands for deca, this H stands for hecto, this K stands for kilo, this M stands for mega, this G stands for giga, and this T stands for tera. Secondly, I write 10 to the power negative 1, then I write negative 2, negative 3, and then I repeat the previous process, jumping 3 times. Negative 6, negative 9, negative 12. I use the trick. Dad can make me nice person. Here, this D stands for deci, this C stands for centi, this M stands for milli, this M stands for micro, this N stands for nano, this P stands for pico. So this is the list of negative prefixes. Thus using this trick, we can easily learn all the prefixes. The fifth topic is scientific notations. Well, a system of writing too big or too small numbers to save space and time is called scientific notation. For example, roundabout, the mass of the earth is 6 into 10 to the power 24 kg. We can see that it is a very big number. So using scientific notation, we can easily save space and time to write it. Also, the diameter of the nucleus is 1.7 into 10 to the power minus 15 meter. It is a very small number, so using scientific notation, we can easily save space and time to write it. The seventh topic is significant figures. The certain or sure and important digits in any measurement are called significant figures. For example, consider this number. Here, we know that 205 are certain or important 3 digits, while this 003 is uncertain, less important 3 digits. So the collection of certain or less important digits are called significant figures. Now let me teach you the most simple trick to find significant figures. I write non-decimal numbers and decimal numbers. In case of non-decimal numbers, go from non-zero digit to last non-zero digit. For example, consider this number. Here, the first non-zero digit is 1 and the last non-zero digit is 2. So I go from this 1 to this 2. Now I count the total digits in this number. There are 6 digits in this number, so there are 6 significant figures. Similarly, consider this number. The first non-zero digit is 4 and the last non-zero digit is 5. I go from 4 to 5. So there are 3 digits. I say there are 3 significant figures. Thirdly, consider this number. Here, the first non-zero digit is 1 and the last non-zero digit is 3. So I go from 1 to 3. There are 3 digits. I say there are 3 significant figures. Now in case of decimal numbers, I go from first non-zero digit to last digit. For example, consider this number. Here, the non-zero digit is 2 and the last digit is 0. So I go from 2 to 0. We can see that there are 3 digits in this number, so there are 3 significant figures. Secondly, consider this number. The first non-zero digit is 1. So I go from 1 to the last. There are 4 digits, so there are 4 significant figures. Thirdly, consider this number. The first non-zero digit is 5, so I go from 5 to the last. There are total 5 digits, so I say there are 5 significant figures. Thus, using this simple trick, we can easily learn significant figures. The seventh topic is accuracy and precision. Accuracy means that how close you are to the actual value. For example, consider this man. Let the height of this man is 5 meters. Let I ask 3 students to find the height of this man. Let the first student measured it as a 4 meter, the second student measured it as 4.5 meter, and the third student measured it as 5 meter. Now these are the 3 different measurements. We say that this whole measurement is accurate result, or we say that high accuracy, because the one measurement is exactly 5 meter, which is matching the actual height of the man. So the actual measurement is also 5 meter and this measurement of the student is also 5 meter. So they both are intersecting or touching each other. So we say that this measurement is accurate or it has high accuracy. On the other hand, precision means that how does 2 or more measurements are close to each other. For example, consider the man from the previous example. We know that the actual height of the man is 5 meter. Let I again ask 3 more students to find the height of this man. Let one student measure the height of this man as 3.5 meter. The second student also measured 3.5 meter and the third student measured it as 3.4 meter. Now let me ask you, are these 3 measurements are accurate? Your answer is no, because the actual measurement is 5 meter and the measurements of the students are totally different from them. But wait a minute. Here we can see that this 3.5 and this 3.5 are close to each other, while this 3.5 and this 3.4 are also close to each other. The results of students are close to each other, so it has high precision. So we say that the first measurement of the student is close to the second measurement of the student, and the second measurement of the students is close to the third measurement of the students. So we say that it has high precision. Thus remember that it has high precision but low accuracy. Now let me teach you some important MCQs. A scale measures the mass of an apple as constantly as 0.5 kg less than the actual mass. The options are accurate and precise, accurate and non-precise, precise but not accurate. Which one is right? Well, the C option is 100% right. 0.5 is precise because the scale is constantly measuring 0.5 kg, 0.5 kg and 0.5 kg. But this result is not accurate because it is less than the actual mass. The mass of a bag is 10.5 kg. A student measured it as 12.5 kg, 10.6 kg, 9.5 kg. The options are precise but not accurate, accurate and precise, accurate and not precise. Can you guess the correct option? Well, the correct option is C. It is accurate because one measurement of the student is matching the actual measurement. On the other hand, it is not precise because 9.5 kg is way different from 10.6 kg. Thus, this is all about accuracy and precision. Remember that we will not discuss topics of 9th class which we have already learned, like atomic masses, relative atomic masses, atomic mass unit, percentage composition, etc. So the next important topic is dimensional analysis. The process of converting one set of units to another is called dimensional analysis. For example, convert 3045 meter to kilometer and 35 degrees centigrade to Kelvin. We know that in 1 kilometer there are 1000 meter. So I divide 3045 meter by 1000. I get 3.45 kilometer. On the other hand, in 1 degree centigrade there are 273 Kelvin. So 35 plus 273 is equal to 308 Kelvin. Thus, this process of converting units from one set to another is called dimensional analysis. The ninth topic is laws of chemical combination. Well, there are 5 different laws or 5 subtopics that describe the basic rules by which atoms and molecules combine together. The first law is law of conservation of mass. Remember that it is all about the mass. It states that mass can neither be created nor destroyed in a chemical reaction. For example, consider 2 grams of hydrogen and 16 grams of oxygen. When they both react together, they form water. Now, if we measure the mass of the water, it would also be 18 grams. So we say that the mass of the reactants is 18 grams and the mass of the product is also 18 grams. Thus, they both are equal. That's why we say that mass can neither be created nor destroyed in any chemical reaction. The second law is law of definite proportion. Remember that it is based on ratio of masses. The word definite proportion means fixed amount. It states that chemical substances are made up of elements that are present in fixed ratio by mass. For example, consider water and hydrogen peroxide. In water, the ratio of hydrogen to oxygen is 2:1, while in hydrogen peroxide, the ratio of hydrogen to oxygen is 1:1. It shows that the ratio of oxygen and hydrogen would always be 2:1 in the water, while the ratio of hydrogen and oxygen in hydrogen peroxide would always be 1:1. Therefore, we say that chemical substances combine in fixed ratio by mass. The third law is law of multiple proportion. It is very difficult for students, but I will crack it. It is also based on ratio of mass. Now consider 2 elements like X and Y. Let they form 3 different compounds, XY, XY2, XY3. Now we can see that the ratio of X in all these 3 compounds is 1, while the ratio of Y in all these 3 compounds is 1, 2 and 3. Now listen carefully. We say that if Y combine with the same element X, the ratio of Y is whole number like 1, 2, 3. Let me repeat it. If Y combine with the same element X, the ratio of Y is the whole number like 1, 2, 3. This is what the law of multiple proportion explains. Let me give you one real example. Consider carbon monoxide and carbon dioxide. In carbon monoxide, the ratio of masses is 12:16, while in carbon dioxide, the ratio of masses are 12:32. Now dividing this whole thing by 12, in carbon monoxide, the ratio of carbon is 1:1.3, while in carbon dioxide, the ratio of carbon is 1:2. So the ratio of carbon is 1 in both the compounds, but the ratio of oxygen is 1:2, which is again whole number. Therefore, this law states that When two elements like X and Y form two different compounds, the ratio of the mass of Y can be expressed as whole numbers. So this is what the law of multiple proportion teaches. The fourth law is Gay-Lussac's law. Remember that it is based on volume of gases. It states that pressure is directly proportional to temperature. For example, consider oxygen gas in this cylinder. If we increase the temperature of the gas, the rate of collision of oxygen molecules on the wall of container is increased. As a result of this, pressure is increased. So we say that pressure is directly proportional to temperature. The fifth law is Avogadro's law. Remember that this law is based on volume and mass of a gas. It states that volume is directly proportional to number of moles or mass of the gas at constant temperature and pressure. For example, consider these balloons. As you fill these balloons with more air or more mass, their volume increases. Remember that we can also write Avogadro's law as equal volumes of any two gases at constant temperature and pressure contains the same number of moles or same masses. For example, consider 2 cube hydrogen gas and 2 cube of oxygen gas. Let they both are present at constant temperature and pressure. So we say that they both contain equal number of molecules. Thus noted down these laws of chemical combinations. The 10th topic is mole and Avogadro's number. In our daily life, we say that 1 dozen egg is equal to 12. So we say that 1 dozen is nothing but just like a number. Now to learn the concept of mole and Avogadro's number, we should learn relative atomic mass and molar mass. For example, the relative atomic mass of carbon is 12 AMU. Remember that there is only one atom of carbon present. Now we cannot touch, we cannot see, and we cannot do chemistry with one atom of carbon. To solve this issue, scientists put forward the idea of molar mass. Now instead of 12 AMU, if I take 12 grams of carbon, it is known as a molar mass. Remember that we can touch, we can see, we can do chemistry with molar mass of carbon. We know that in 12 AMU, there is only one atom of carbon, but in 12 grams, there are total 6.023 into 10 to the power 23 atoms. Thus this number is known as Avogadro's number. Thus remember that in 12 grams of carbon, there are 6.023 into 10 to the power 23 atoms. Now listen carefully. 1 mole is always equal to molar mass of an atom, molecule or formula unit. Also we know that molar mass of any atom like carbon, molar mass of any molecule and molar mass of any formula unit contains 6.023 into 10 to the power 23 atoms. So remember that 1 dozen of anything is always equal to 12. 1 mole or molar mass of any atom, molecule or formula unit contains 6.023 into 10 to the power 23 particles. If you want to learn more about mole concept and Avogadro's number, we have already uploaded a very dedicated video and its link is given in the description. The last topic is molarity and molality. Now molarity is the number of moles of solute dissolved in 1 liter solution. Remember that we do not consider solvent and molarity. For example, consider some water in this object. I add 2 mole sugar to this water. After adding 2 mole sugar to this water, the volumes of solution becomes 1 liter. So we say that the solute is sugar and we have dissolved 2 moles of it. The solvent is water. The volume of solution is 1 liter. So the molarity of this solution is 2m because we have dissolved 2 moles of sugar in 1 liter. Remember that the formula of molarity is number of moles of solute upon volume of solution. On the other hand, molality is the number of moles of solute dissolved in 1 kg of solvent. Remember that we do consider solvent in case of molality. For example, firstly, I take 1 kg of water in this object. Now let's consider that I add 4 mole of sugar to this 1 kg of water. Now we know that the solute is sugar and we have dissolved 4 moles of it. The solvent is water and the mass of the solvent is 1 kg. So the molality of this solution is 4m because we have dissolved 4 moles of sugar in 1 kg of solvent. Remember that molality is denoted by small m and it is equal to number of solute upon mass of the solvent in kg. I hope that you have learned the important concepts of first chapter of chemistry.